Mathematics Olympiad. We are solving for n in this exponential equation. How do we go about it? So this is what we do. We multiply through by 2 exponent 4. Next, we evaluate 2 exponent 4 to get 16. Then this is what we do next. We rewrite 2 exponent 3n as 2 exponent n all exponent 3 because we can multiply the 3 by the n to get the 2 exponent 3n back. The same thing applies here. Then what do we do next? Remember, we expanded the right hand side here. Next, we let 2 exponent n be equal to a variable x. Now we have reduced this exponential equation to a cubic equation. Let us now rewrite in a standard cubic equation form so that we can factor. So let's factor. By inspection, we can factor x squared here, and we can factor negative 16 here. This will factor further to obtain x squared minus 16 times x squared plus 1. So either x squared minus 16 equals 0 or x plus 1 equals 0. So we have x squared to be equal to 16 or x to be equal to negative 1. Solving these, we obtain x to be equal to negative 4, positive 4, or negative 1. But recall that our x, we started with the variable n, so we have to do back substitution. So 2 exponent n is either equal to 4, negative 4, or negative 1. But these two equations here cannot be solved for n because we don't have negative value. The exponential equation here can never be negative. It is always above the x-axis. It means that 2 exponents n is equal to 4, and that will be what will give us the equation. And by comparing the exponents, we write 4 as 2 exponent 2. By comparing the exponents, we have n to be equal to 2 because the base is the same. Hence, the value of n is 2. Now we can check by substituting 2 into the original exponential equation. And when we evaluate these, we obtain 64 plus 16, which is 80 over 16. And that will give us 5. So 5 is equal to 5.